CBXFEL, cavity-based X-ray free electron laser, and it's in a research and development experiment. What the physicist wants to demonstrate is that when they will manage to make the X-ray recirculate the X-ray and come back and interact with the electron beam, they will manage to amplify and improve the properties of the accelerator, and they will be able to produce a higher range of energy, of X-ray energies, and a brighter X-ray laser.
Welcome back to Chelonia Podcast, a podcast about the use of scientific discoveries and technology application. We provide the best information on projects participated by Chelonia and many more. My name is Gabriella Bernardi, I'm a science journalist, and in today's episode of the second season, our guest is Giulia Lanza, vacuum engineer and manager of the CBXFEL project at SLAC National Accelerator Laboratory. It's a pleasure to meet you, and would you please briefly introduce yourself?
Hi Gabriella, nice to meet you. Thank you for inviting me to your podcast. Starting from the beginning and from what mattered most to me, I'm a daughter, I'm a sister, I'm Italian, I play beach volleyball, and I happen to be a materials scientist that studied at Padova University and now is working at SLAC National Accelerator Lab in California. I did my PhD in material science in Padova in collaboration with INFN Legnaro, the Istituto Nazionale of Fisica Nucleare, and for 6 years before coming here, I worked at CERN mainly for the big LHC Large Hadron Collider accelerator for its vacuum system. In 2016, I moved here to California to work at SLAC. SLAC is run by the Stanford University, and it is funded by the Department of Energy. And I came here to support the upgrade of the linear accelerator that they have here at SLAC that is called LCLS. That stands for Linear Coherent Light Source.
Perfect. And what does a vacuum engineer do, and what are her responsibilities as SLAC?
So let's first start what is vacuum. Vacuum is defined as a state where the pressure is lower than the atmospheric pressure. So there are different levels of vacuum, but it's practically a technology that removes gas from either a chamber or a vessel or a closed environment. And the vacuum engineers are experts in the vacuum technology, so in the technology and the material science that is important to remove this gas from the chamber. Why we remove this gas from the chamber? Because we don't want the atmospheric gas, the air, to interact with either the reaction that is happening in your chamber, or in the case of accelerator, with the beam, with the particles that are passing through the accelerator. So this gas needs to be removed, and that's what a vacuum engineer does. The fact that I am a material scientist and I'm expert in material processes helps a lot in vacuum engineering, because I know different type of materials, I know how to process them from the point of view of thermal and chemical processes, and so I can help the mechanical engineer in designing all the components that goes into the accelerator, prepare them, choose the material, and also process them so they can meet the vacuum level that is needed in that area of the accelerator. So this is what I do. Mainly I work with mechanical engineers and I support them in designing and preparing the correct processes and procedure to build all the components that goes into an accelerator, so they meet the vacuum requirement for that area of the accelerator.
Very, very interesting. And which are you working on now, or what are your future projects?
So let's talk a little bit about the accelerators that we have at SLAC, the linear coherent light source. The accelerators are machines that use electromagnetic field to propel charged particles to a very high speed and energy, and they contain them in a well-defined beam. So these particles are in a defined space and time. So at SLAC, we accelerate electrons. We accelerate electrons in a linear 2 miles, so 3 kilometers approximately, accelerator to produce at the end of the accelerator a X-ray laser. So the electrons gets wiggle at the end of this accelerator, and they produce a very coherent source of X-rays. And these X-rays can have different energies, and then can be applied to different studies. You can study condensed matter, you can study, for example, lithium batteries, you can study plasma, but you can also study biological samples or chemical reactions. And at the moment, I'm working on a very interesting project. It's called CBXFEL, Cavity-Based X-ray Free Electron Laser, and it's in a research and development experiment. What the physicist wants to demonstrate is that when they will manage to make the X-ray recirculate the X-ray and come back and interact with the electron beam, they will manage to amplify and improve the properties of the accelerator, and they will be able to produce a higher range of energy, of X-rays energies, and a brighter X-ray laser. These X-ray lasers are important because researchers from all over the world, all over the United States, are coming here to use this laser to do their studies. So they have lots of application. And the more we can control, the more we can improve the capabilities of our accelerator, more research we can do, and a lot of other people can come and do their studies in our facilities.
Very, very impressive. And do you think that the technology development needed at SLAC will have a future application?
So there's a lot of I talked only about the accelerator because this is what I'm doing right now, but there's a lot of technology happening at SLAC. There is quantum application technology. We do electron microscopy. We build telescope to look at the sky. So there's a wide variety of technology that has been developed. The difference between, for example, the LHC, the Large Hadron Collider in Geneva, that is only for basic science, so they study new particles. Well, the LCLS that here at SLAC is made for users. So the accelerator is used externally by also external companies to come in here and do their studies. So the technology that we are developing here has a great impact on the knowledge and the well-being of the population and the community. Then the technology that we develop for Accelerator has also a wide variety of application, because smaller accelerator are used, for example, in hospital for oncological purposes or for medical tests that using isotopes, but are also used in, for example, semiconductors industry. So everything that has to do with semiconductors, because semiconductors are material that are doped. That means have other implanted ions in it. And to implant those ions, you need an accelerator. So there's wide variety of applications for the technology that we are developing.
Fantastic. Now we are in the Women and Girls in Science Month. What is the SAGE journey? Can you talk about it?
So SAGE Journey is a program that came from an idea that I developed in 2018 together with my co-founder, Diana Gamzina. We came up with this SAGE Journey program that is really thought for curious and passionate students that want to explore what kind of career possibility they have for their future. And the mission of SAGE is to really increase the gender diversity in the national laboratory workforce. So the SAGE Journey is a program that follows our students from high school throughout their career. It starts with a summer camp, where students from, for example, California, but now these summer camps are 7 and they are all over the national labs in the US. The students come and get to interact with scientists, engineers, managers, technicians, all the people that work at a national laboratory. So it's an experience, and they get to know these people, what they do during their daily work, but also what are their hobbies, how a scientist and engineers and a manager at a national lab look like. So they get to see a lot of careers and explore what and meet role models that can create a new image of what does it mean to be an engineer and a scientist at a national laboratory. So they get to explore, they get to stay at the campus at Stanford, they come here at SLAC, they do a lot of experiments, listen to talks, go on tours to visit the accelerator. So it's a week, or it depends, in other labs it's 2 weeks of a lot of fun. And then we stay in contact throughout their high school. Usually, sometimes they create clubs that are SAGE clubs in their school. And then we always hope that these students come back as interns at the national labs when they are at their college age. So the idea is to really stay in contact with their students and have them come back and work with us at the national labs when they start studying all the classes, or the physics class, but also math and economics, all the classes that they need to actually be able to work a summer here.
Congratulations for this. And we are at the end of this podcast, but why did you choose to work in your field, and what or who inspired you?
So after high school, I didn't have any experience in what were the career possibilities. So I was a little bit undecided, but I knew what subjects I loved. I had chemistry, I loved math, physics, but nothing really, I was undecided. And when I discovered material science, I found out that it was a great mix of all the three subjects, and it really gave me the flexibility of choosing any field that I really wanted. My colleagues are working in the automotive field, in steel industry field. They work still at national labs. They work in thin film, in semiconductors. There's really a wide variety of fields where you can find material science application. So it gave me the flexibility to really choose. But then I attended one course from Professor Palmieri at the end of my 5 years of university, and I really loved the subject of thin films and vacuum application. And so and that year I also participated to the summer camp at CERN, and I spent 3 months at CERN working with scientists and engineers, and I really decided that was the place I wanted to work in. And that's the idea of SAGE, right? It was really inspired by how much impact that experience had a huge scientific laboratory on me, and we want to really give these possibilities to a lot of our students.
Thank you, Giulia Lanza, and thanks our listeners. If you have any question about today's podcast, you can get in touch on Chelonia Twitter, and feel free to subscribe chelonia.swiss website and be part of the community. In meantime, stay tuned for our next interview.